Good day. Today we will be discussing moments. And this is what we should know about moments. We should know the definition. We should know the formula. We should know the direction of movements, and lastly the principle of movement. Let's jump right onto it. So what is a moment? A moment is the turning effect of force about a pivot. A moment is the turning effect of force about a pivot. So let's picture this. We have a seesaw and it has a pivot, and let's say we apply force right about here. The moment in this case will be the force applied multiplied by the distance from the pivot. So our moment will be the force multiplied by the distance, which is our formula for moments. So what about the direction of moments? So we have two directions. We have the clockwise movement. And the anti-clockwise movement. Clockwise movement is this direction and anti-clockwise movement is this direction. And as for the principle of movement, you should know that the clockwise movement is always equal to clockwise movement. So in definition, we would say for an object to be in equilibrium or not moving, the total clockwise movement must be equal to the anti-clockwise movement. So using the seesaw example, as to explain the principle of movement, we would say for this thing to be in equilibrium, the sum of clockwise movements should be equal to the anti-clockwise movements. So let's take an example. To apply the formula. So let's do this example. Question 1 says a 10 Newton force acts at 3 meters from a pivot. What is the moment? So as mentioned, you have to apply this formula here. So in this case, we are given the force, which is 10 newtons, and we are given the distance, which is 3 meters. You just apply the formula here and substitute. So moment is equals to force times distance. We are given 10 newtons and a distance of 3. What is your momentum? Grab your calculator. So this becomes 30 Newton meters. This is your answer for question 1. And question 2. Question 2 says a beam is balanced at the left side being 50 newtons at 2 meters and the right side being the unknown force at 4 meters. So in this case, we are looking for the force. So what do? We have to apply the principle. We have to apply the principle of moments. So just for visualization, the beam is balanced at a pivot of from the left to the on the left side as 2 meters. So we have a force here, and on the right side we have our unknown force at 4 meters. So here we apply our principle of moments, right? So let's do it. Principle says clockwise moments is equals the anti-clockwise moments, right? So in this case, force times distance is equals to force times distance. On the right side we don't know our force, so we're going to keep it as F, but we know our distance, which is 4 meters. And on the left side we have our force, which is 50 newtons, and our distance being 2 meters. So in this case, we just make F the subject of the formula. And how do we do it? So we're gonna have F being 50 newtons multiplied by 2 meters all over 4 meters. Grab your calculator and work it out. Calculate. 50 times 2 is 100 Newton meters all over 4 meters. Distance cancels distance. Now we are left with 100 divided by 4, which is 100 divided by, grab your calculator, 25. And now we have our force here. So to verify if your answer is correct, you can just substitute this force over here and you should get the same moment on both sides. So let's just do it. 50 times 2 is equals to is equals to 25 times 4. If you multiply 25 by 4, you get 100 Newton meters, and you multiply your 50 by 2, you get 100 Newton meters. So this verifies your answer. Here, figure 1 shows a uniform fluorescent lamp of length 1 meter and 8 newtons. The lamp is suspended using 2 strings, S1 and S2. So note that when dealing with strings, we represent our force. We represent our force in tension. So when dealing with strings, instead of F, we use T as our force, right? So question A says, taking moments about S2, calculate the tension in string 1. Calculate the tension in string 1. Taking moments about S2, calculate the tension in string 1. So first thing, when taking moments about a point, you nullify everything that is at that point. So in this case, we have S2 as our point. So we're going to ignore S2 and use everything that is about S2. So you have to know, you also have to apply the principal rule, the principle of moments here. So in this case, we will be having anti-clockwise equals to clockwise moments, right? So you have to understand the forces, how to take forces in this beam. Everything that is above the beam with an arrow facing up is clockwise. And everything that is below or below the beam or the arrow facing down is anti-clockwise. So let's try to apply this analogy here. Applying the formula, F times D equals to F times D. We need to know the distance from S2 to the force, 8 newtons, and we need to know the distance from S1 to from S2 to S1. So in this case, we know we have, for anti-clockwise, we have newtons, 8 newtons, 8.0 newtons. At distance, we don't know the distance, we're gonna have to calculate it. So the distance, we know that the length of the beam is 1 meter, and at the center of it is 8 newtons. So it's going to be 0.5 minus 0.35, which gives us 0.15 meters. So our distance will be 0.15 meters here. Then for clockwise moments, we go back to our drawing board. S1, so we don't know what S1 is. We don't know the tension at S1, which is, we replace F with T, and the distance from S2 to S1 is 0.55 meters. So what do? You make T the subject of the formula, and you should get 8.0 newtons times 0.15 all over 0.55 T1. So, and the answer is, calculate that, you should get 2.18 newtons. Yeah, 2.1 meters cancel meters, you're left with that. So now, from question A to B, we should now determine the tension in string S2. tension in string as 2. Okay, sorry. So in this case, what you should know that the upward force is equals to the downward force. So we've already calculated T. So we've already calculated T, of which we know T. So we have to sum up all forces above, the upward force, to sum up all forces above and equate them to all forces below. So we only have one force below, which is 8 newtons, and two forces above, which is T1 and T2. So upward forces T1 plus T2, downward forces we only have 8. So in this case we are looking for the tension in string 2. So we already know tension at string 1 is 2.18 plus T2, which we are looking for, equals to 8. Equals to 8. Make T subject of the formula, you get 8 minus 2.18. Your T2 is, grab your calculator, calculate 8 minus 2.18. 8 minus 2.18, you get 5.82. Get 5.82. And your tension at string 2 is 5.82. So we both have our forces. You can just cross check this by replacing this here and adding them together to see if you will get 8, because they have to be equal. So 2.18 plus 5.82 is equals to 8, of which your answer here is correct. Your answer here is correct.